Scientists say the ice sheet beneath 2 miles of ice, Greenland, is revealing things that were never meant to be seen again. This is not one strange discovery, but a chain of hidden systems rising at the same time as melting ice unlocks what has been sealed for millions of years. Scientists now see that Greenland is not simply shrinking, but waking up. And some of what is emerging no longer follows old models or safe predictions. For the first time, researchers openly admit they do not fully understand how far this process can go. If the ice is exposing more than water, what else is coming next from below? For a long time, scientists believed Greenland's ice behaved in a simple way. When temperatures rose, the surface melted and the water slowly flowed away toward the ocean. That idea no longer holds. What researchers are seeing now is ice that does not just melt, but actively moves, reacts, and accelerates in ways that were never expected. The change begins on the surface during warmer months. Meltwater gathers into streams and lakes that look harmless from above. Yet gravity pulls that water downward through cracks in the ice. Over time, those cracks widen and turn into massive vertical shafts that can stretch hundreds of feet deep. Scientists call them moulins, but a simpler way to picture them is as giant pipes drilled straight through solid ice. Instead of spreading out, water now travels fast and directly into the heart of the ice sheet. Once the water reaches the base, it does not easily escape. The ice above acts like a heavy lid, trapping liquid against the frozen ground below. As more meltwater arrives, pressure builds. This pressure does not just sit quietly, it pushes upward and outward, lifting parts of the ice sheet slightly and reducing friction at the bottom. In effect, the water turns the base of the ice into a slippery surface, allowing entire sections to slide toward the sea faster than scientists once thought possible. What makes this process especially dangerous is that these vertical pipes do not close after a single season. For years, they remain open, acting as permanent drains that deliver summer meltwater straight to the bottom of the ice. Earlier models assumed glaciers healed themselves over time, sealing cracks as cold returned. New observations show the opposite. The damage stays, and each warm season sends more water through the same pathways, deepening the internal weakness of the ice sheet. Measurements taken over the last decade reveal how dramatic the shift has become. In some regions, the speed at which ice moves toward the ocean has increased by more than 50% compared to late 20th century averages. That change does not happen over centuries. It can unfold within a single decade. This is why scientists now describe parts of Greenland as unstable rather than slow-moving, a word rarely used for ice of this scale in the past. The global risk lies in how this movement affects sea level. Greenland holds enough frozen water to raise oceans by several meters if fully released. Faster sliding means more ice reaches warmer coastal waters, where it breaks apart and melts even more quickly. Each summer, billions of tons of fresh water pour into the North Atlantic, adding stress to ocean systems that regulate weather patterns across the planet. What alarms researchers most is that this behavior breaks old assumptions. Ice was once treated as a solid mass that responded gradually to heat. Today, it behaves more like a dynamic system, reacting to pressure, flow, and feedback in real time. Greenland is no longer just losing ice at the edges, it is changing from the inside out. If water can punch through miles of ice and turn it into something that moves instead of rests, the next question becomes unavoidable. Where exactly is all this water going once it disappears below the surface? Greenland's ice is not collapsing at random, because beneath it lies a hidden structure that quietly controls where meltwater goes and how fast the ice above can fail. Scientists discovered this only recently, and the scale of it changed everything they thought they knew. Deep under more than a mile of ice, radar revealed a massive canyon carved into the bedrock, longer than the Grand Canyon and deep enough to swallow skyscrapers. This canyon is not a crack formed by melting ice, it is an ancient river system that existed long before Greenland was buried under ice. Millions of years ago, when the island was ice-free, water carved this channel across the land. When ice later formed on top of it, the canyon did not disappear. It was sealed, frozen in place, and forgotten. Today, that ancient landscape has become active again. As meltwater pours down through the ice, it finds this buried path and follows it toward the ocean. Scientists describe it as a superhighway because it moves water efficiently from the center of Greenland straight to the coast. Unlike surface streams that can slow down or spread out, this underground route directs flow with precision and force. What makes this discovery so dangerous is the canyon's position. In many places, its floor lies below sea level. That means water moving through it does not pool or freeze easily. Instead, it keeps flowing, carving space beneath the ice and weakening the structure above. As more water enters the system each year, the highway carries a heavier load, accelerating the loss of ice from inland regions that were once considered stable. Satellite measurements and ice-penetrating radar now show that areas above this canyon respond differently to warming than surrounding regions. Ice over the channel tends to move faster and thin more quickly, even when surface temperatures are similar. This tells scientists that melting is not just about air temperature, it is also about what lies beneath, quietly shaping how the ice behaves. The most unsettling part is that this system was not created by modern climate change. It was built by ancient geology and only reactivated by today's warming. Greenland is not inventing new weaknesses, it is reopening old ones that were locked away for thousands of centuries. The ice sheet is losing mass along pathways that were carved long before humans existed. This changes how scientists think about prediction. If ice loss were evenly spread, models could estimate future sea levels with more confidence. A hidden drainage network breaks that assumption. It concentrates movement, funnels water, and creates zones where collapse can happen faster than expected. Greenland's future is being guided by a map written deep in stone. As researchers trace this underground highway, one question grows louder. If water can travel unseen across the island beneath the ice, what else is hidden down there, shaping Greenland's fate without ever touching the surface? Greenland's surface is changing color, and that shift is one of the clearest signs that ancient biological systems are waking up. For thousands of years, the ice acted like a giant mirror, reflecting most sunlight back into space. Today, large areas no longer shine white. They're turning darker, and that change is speeding up everything that follows. The cause begins with microscopic life. On melting ice, tiny organisms known as ice algae start to grow. To survive intense sunlight, these algae produce dark pigments which spread across the surface as temperatures rise. Dark ice absorbs far more heat than clean snow, so once the color changes, melting accelerates. More meltwater creates better conditions for algae, and the cycle feeds itself. Scientists now see this biological feedback as one of the strongest forces driving rapid ice loss. What makes this discovery unsettling is that algae are not the only life forms returning. Deep within the melting ice, researchers have identified giant viruses that were frozen for thousands of years. These viruses are far larger than typical ones, sometimes bigger than bacteria, and they were once thought to exist only in soil or ocean environments. Finding them active on the ice sheet suggests that Greenland is releasing biological material that has been locked away since long before modern ecosystems formed. Some scientists believe these giant viruses may infect the ice algae and slow their spread, acting as a natural control system. Others warned that their reappearance proves a larger point. Melting ice does not just release water, it releases living systems that have been absent from the surface world for millennia. Once exposed, their behavior is difficult to predict, especially in an environment already under stress. The most striking evidence of Greenland's biological past comes from deep beneath the ice, where researchers extracted DNA fragments preserved in frozen sediment. These genetic traces are up to 2 million years old. When analyzed, they revealed a landscape that feels almost impossible today. Northern Greenland once supported trees, shrubs, insects, and large animals such as mastodons. This was not a brief warm moment, it was a stable ecosystem that thrived where ice now dominates. Changes how scientists view the present. Greenland's ice sheet was long believed to be ancient and unbreakable, but the DNA shows it vanished before, even when global temperatures were lower than today. That means the ice is not a permanent shield, it is a temporary state that can disappear under the right conditions. Together, dark algae, giant viruses, and ancient DNA paint a single picture. As ice melts, Greenland is not becoming empty, it is becoming active again, releasing biological systems shaped by climates very different from our own. The island is not just losing ice, it is opening a biological chapter that was never meant to return so quickly. If life that vanished millions of years ago can reappear as the ice retreats, the next question becomes unavoidable. What happens when these ancient systems meet the modern world above them? For decades, scientists believed Greenland's ice sheet rested on hard, stable rock, which acted like a natural break that kept the ice slow and predictable. That assumption is now falling apart. New evidence shows that large parts of the ice are not sitting on solid stone at all, but on thick layers of wet sediment that behave more like mud than rock. This discovery came from listening to the ice rather than looking at it. By using hundreds of seismic stations across Greenland, researchers tracked how vibration waves traveled through the ice and into the ground below. What they found was unexpected. Instead of moving cleanly through hard rock, the waves slowed down near the base of the ice. This delay revealed a soft, water-soaked layer beneath, sometimes hundreds of meters thick. That soft ground changes everything. When ice presses down on hard rock, friction helps hold it in place. When ice sits on wet sediment, pressure causes the ground to deform and shift. The result is a surface that allows ice to slide more easily toward the sea. As surface melting increases, more water drains downward through the ice, raising pressure at the base and making this muddy layer even more slippery. The danger does not stop there. Scientists have also confirmed the presence of subglacial lakes trapped beneath the ice sheet. These subglacial lakes can store enormous amounts of water under intense pressure. In rare cases, that pressure becomes strong enough to break upward through the ice. When this happens, the ice does not crack gently, it fractures violently, lifting sections of the surface and leaving behind deep holes and shattered ice fields. One such event released tens of millions of cubic meters of water in a matter of days. The force was so strong that water moved upward against gravity, a process scientists once believed was impossible in regions like Greenland. These sudden releases weaken the ice from below and leave permanent scars that do not easily heal. Together, wet sediment and pressurized water destroy the idea that Greenland's ice sheet is anchored firmly in place. Instead of a frozen block glued to bedrock, it behaves more like a heavy object sliding on a soaked surface. This makes the system highly sensitive to even small increases in temperature and meltwater. The implications are serious. Many earlier sea level models assumed friction at the base of the ice would slow its movement over time. If that friction is far lower than expected, those predictions may be too optimistic. Ice can reach the ocean faster, break apart sooner, and raise sea levels more quickly than planned for. What makes this especially troubling is that these conditions exist across wide areas of Greenland, not just isolated spots. The foundation of the ice sheet is weaker than scientists believed, and warming is making that weakness more dangerous each year. If the ground beneath Greenland's ice cannot hold it in place, then the next question becomes unavoidable. What happens when this unstable foundation meets the toxic legacy humans left behind under the ice? Hidden beneath Greenland's ice lies a human legacy that was never meant to resurface, yet warming temperatures are slowly pulling it back into view. During the Cold War, the United States built Camp Century, officially described as a scientific research station, but in reality designed to test a far more dangerous idea. The project explored whether nuclear weapons could be hidden safely beneath a moving ice sheet, protected from enemy attacks and invisible to the world above.
Kilometers beneath the surface. Inside, the base housed living quarters, laboratories, and even a nuclear reactor that powered the entire facility. To military planners, the ice seemed permanent, cold, and reliable. They believed it would seal everything away forever. That assumption did not last long. Engineers soon realized the ice sheet was not stable. The tunnel slowly bent and shifted as the ice moved, crushing structures that were meant to remain intact. By the late 1960s, the project was abandoned. The reactor was removed, but much of the base was left behind, including fuel, sewage, and radioactive waste. At the time, officials believed snow would bury the site deeper each year, locking it away beyond reach. What no one planned for was a warming Greenland. As the ice above Camp Century thins and melts, the frozen barrier separating these materials from the environment grows weaker. Scientists now warn that toxic substances stored beneath the ice could eventually leak into surrounding ecosystems. Estimates suggest that within the next century, meltwater may reach the buried waste, carrying contaminants toward the ocean. This is not a distant science fiction scenario. Radar surveys conducted in recent years have already mapped the old tunnel network with surprising clarity. The structures remain aligned exactly where historical records said they would be, proving the site is still intact in waiting. As ice loss accelerates, time becomes a critical factor. The danger is not limited to radiation alone. Diesel fuel, chemical pollutants, and decades of human waste are trapped in a place once assumed to be frozen forever. If released, these substances could damage Arctic wildlife and enter marine food chains relied upon by communities far beyond Greenland. Camp Century changes the story of melting ice in a troubling way. Greenland is not only revealing ancient geology and biology, but also exposing mistakes made during moments of political fear. What was once hidden for strategic reasons now threatens to become an environmental problem shared by the entire planet. As scientists assess the risks beneath the ice, one realization stands out. Greenland is not just a natural system reacting to heat, it is also uncovering unfinished business from the Cold War. And if the ice continues to retreat, the next question becomes unavoidable. How close are we to crossing a point where even human secrets can no longer stay buried? Greenland is approaching a line that cannot be crossed twice, and scientists describe this line as a tipping point rather than a slow decline. A tipping point is reached when a system changes so much that it keeps moving on its own, even if the original cause is removed. In the case of Greenland, that cause is heat added to the atmosphere by human activity. To understand this, researchers look at carbon rather than ice. Since the industrial age began, humanity has released hundreds of billions of tons of carbon into the air. Studies show that once total emissions pass a critical level, parts of the Greenland ice sheet enter a state of irreversible collapse. At that stage, the ice doesn't wait for more warming. Gravity and internal feedback take control. The reason lies in elevation. Today, the top of Greenland's ice sheet sits high in the atmosphere, where air remains cold most of the year. As melting lowers the surface, the ice sinks into warmer air. For every reader it drops, the surrounding temperature increases. Eventually, the ice reaches a height where winter snowfall can no longer replace what melts in summer. From that moment, loss becomes permanent. Scientists warn that this shift does not happen evenly across the island. The southern regions are especially vulnerable because they sit lower and warm faster. Once these areas cross the threshold, the process continues. Even if global emissions suddenly fall to zero, the ice keeps shrinking because the system has already changed its balance. The consequences extend far beyond Greenland. If only part of the ice sheet collapses, global sea levels could rise by more than a meter over time, enough to reshape coastlines and flood major cities. If the entire ice sheet eventually disappears, oceans could rise several meters. This would not happen overnight, but the physical decision would already be made. What makes this moment terrifying is how quietly it arrives. There is no single crack or explosion to mark the point of
no return. Instead, the system slowly shifts until recovery becomes impossible. By the time the change is clear, stopping it is no longer an option. Scientists now emphasize that this is not a warning for the distant future. The processes that lead to irreversible collapse are happening today. Each warm summer, each increase in meltwater, and each loss of elevation pushes Greenland closer to a state it cannot escape. This is why Greenland has become a symbol of climate risk. It shows how natural systems can absorb pressure for centuries, then suddenly respond in a way that cannot be undone. The ice does not need permission to keep melting once the balance is broken. As researchers watch these thresholds approach, one question hangs over the entire discussion. If Greenland is nearing a point where stopping emissions is no longer enough, what other systems on Earth might be closer to their own invisible limits? Deep in the dark, icy waters surrounding Greenland lives a creature that has quietly watched centuries of change unfold. The Greenland shark is not famous, fast, or dramatic, yet it may be one of the most important witnesses to the island's transformation. Some of these sharks have been alive for nearly 400 years, meaning they were already swimming beneath the ice when the first modern cities were still being built. Scientists confirmed this astonishing age by studying proteins in the shark's eye lenses. These proteins form before birth and never change, allowing researchers to measure their age using radiocarbon dating. The results shock the scientific world. The Greenland shark is now known as the longest living vertebrate ever recorded. This extreme lifespan is tied to how the shark survives. It lives in near freezing water, moves slowly, and has a metabolism that barely changes over time. Instead of growing quickly, it adds only about 1 centimeter per year. Its body repairs damage at a pace that matches its environment, and genetic studies suggest it carries strong defenses against cancer and inflammation. In many ways, the shark's biology feels perfectly designed for a stable, frozen world. Yet, this ancient survivor also reveals a hidden weakness. Greenland sharks take more than a century to reach sexual maturity. This means their populations recover incredibly slowly. Losing even a small number of individuals can affect their numbers for generations. For an animal that evolved in a world of slow change, sudden disruption is a serious threat. As Greenland warms, the environment these sharks depend on is shifting faster than they can adapt. Changes in ice cover affect ocean temperature, light levels, and food availability. Increased human activity, including fishing and pollution, adds new pressures to a species that was never built to handle rapid change. What once protected the Greenland shark now leaves it exposed. The shark's long life gives it symbolic power. It has survived the Little Ice Age, the Industrial Revolution, and 2 world wars. It has endured while empires rose and fell. But climate change is different from anything it has faced before. This is not a slow cycle that unfolds over thousands of years. It is a sharp turn happening within a single lifetime. Scientists now view the Greenland shark more than a biological curiosity. It is a living record of stability, proof that the Arctic once changed at a pace that allowed life to adjust. Its current struggle highlights how unnatural the speed of today's warming has become. If a creature built to survive centuries of cold is now under threat, the message is difficult to ignore. Greenland's changes are not abstract numbers or distant models. They are already affecting living beings that once seemed untouchable. As researchers follow the fate of these ancient sharks, a deeper question begins to emerge. If even the oldest witnesses of the Ice Age are running out of time, what does that say about the future waiting beyond the melting ice? The most unsettling discovery is not a crack in the ice, but proof hidden inside it. Sediment from deep ice cores shows that central Greenland once held tundra, plants, and flowers, meaning the entire island melted before during a cooler Earth than today. This reveals Greenland as a sensitive system, not an unbreakable shield. What is happening now is not impossible.
It has already happened once. If this frozen giant can awaken again, understanding it becomes urgent, not optional. Watch closely, stay curious, and share this story. How much time do you think remains before Greenland changes everything we know? Amazing discoveries. Make sure to subscribe and hit the bell icon. Share this video with friends and join the discussion on what these findings could mean. Your thoughts and questions are important, so let's explore incredible mysteries together.